Hello community, so great that you are back. Yes, today we have a brand new topic. It is about contextual instantiation. So if you have a huge AI intelligence, how do we bring a little bit of intelligence here to our AI agents? Let's have a look. Welcome to my channel, Discover AI. We have a look at the latest AI research paper. And of course, in very short time, everybody will have a happy agent in its home, in its environment, real close, and we will be all a community of very happy, smiling, beautiful, everything AI agents. Great. Well, until we find out that we have some new AI research paper that highlight a significant flaw in the current agent design. So, let's jump into this video. Let's find a solution. I have a problem and a solution for you, so we can have this happy future together. Now, in this new research, I'm going to show you, they discovered a narrative overfitting of multi-agent system. So this means our agents value the consistency of the conversation history between multi-agents more than the ground truth of the data. This is not really helpful. No, this would be a catastrophe if we would leave here these AI agents out in the real world with human interaction because they care more about their conversation history than the truth of data. So, for an AI researcher, this is now a double-edged sword, because think about this. The conversation history is also about bringing in memory. And this memory is here in the simplest way a RAG system that brings in an external data stream from a database, or you go with a medical record system in a hospital, no? And suddenly we have a problem, because it provides context, which is great, but it also creates an anchor which weighs down an AI agent reasoning. And you might say, but this is nonsense. This is not possible. What institution says this? Yeah. I'm so glad that you asked. Welcome to Stanford University, very latest publication. It is not November 6th, but it is November 19th. But yeah, they made a little mistake in the date. Never mind. They talk about probing here the belief formation in role-primed LLM agents. So, large language model, great. We can build with them our agents. They have a memory, they have internet connectivity, they have access to databases, beautiful. And then we have a role-primed LLM agent. So this means we tell our agents, now you behave like a financial analyst, or now you behave like a teacher explaining whatever. Those are role-primed situations. And now we have a look into the internal working and the internal understanding, and we will probe here the belief formation in those machines. So this role prompt, what we call now a persona, brings with it a large set of priors. And you will be surprised, because it's not the priors that you know, but there are some hidden dark priors that we also integrate. Stanford University, medical department, beautiful. We have some human medical expert. They consult each other here on a specific case. This is what you know. Well, maybe in the next years, you will not have here humans sitting, but 4 AI agents. So what's going to happen? Each clinical AI agent here, now they go here in the Stanford study with a psychiatrist, neurologist, a rheumatologist, and pediatrician. All those agents are instantiated with a fixed persona. And I'm going to show you the prompt for this persona in a minute. So they define that every agent has a particular role. And you're saying, yeah, great, this is fantastic. Now they can focus on their area of expertise. In this persona prompt, if you look a little bit closer, Stanford found that it should have 4 layers. At first, you have the role identity. What do you say? Hey, you are a general pediatrician, blah, 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 20 years experience. But then you also give it a operational heuristics because it needs this. And so you tell the AI, hey, you are cautious about overdiagnosis and you avoid ordering unnecessary labs because, maybe the insurance does not cover here these very expensive lab results, so you get the idea. Then, of course, you can have specific literature anchors. This is here all the textbook on neurology, I don't know, 100, 1000 textbooks. AI just reads it all. Beautiful, done. If you are in a particular cultural sphere, like in the US, you read the US recommendation or the US guidelines for, you get the idea. Then we have the logic engine, the referral logic. So those are explicit instruction, like, and this is now really from the human experience also, when you just dump your patient to the next specialist to simulate here real-world gatekeeping. Because everybody is only a specialist in a very narrow topic, and if your analysis doesn't help, you just send it off to the next specialist. It's a real-world experience. Now, Stanford tells us, you know what? When we allowed the agents to communicate to each other, we encountered a problem because they were just talking over each other, not ingesting the data stream or respecting here the insights. So they said, okay, no way that then one agent talks to the another agent. So what they had now is, okay, let's build a database. And every agent in a linear sequence gets a chance. So one agent starts, says, okay, I'm a neurologist, I see this patient, and I now write here my diagnosis here after my talk or whatever, analysis in these medical records. Then comes the next agent. Looks at the patient, looks at the remarks from the first, let's call it medical specialist. And now this is now a pediatrist and says, okay, I see now the following symptoms. I have here the following diagnosis. So you see, we go here over a very controllable experiment that Stanford does, because we can go step by step. We have breakpoints, we have interrupts where we suddenly can rewind or we can insert new data. We can change a little bit the flow of the conversation. We say, hey, let's make an experiment. Imagine you would have a new result coming in. How would it now change here the diagnosis of a medical AI system? They want to understand where are the thresholds. Now, I could show you this boring, whatever, visualization from the last century, but come on. I built for you, for my viewers, an interactive app to show you this beautiful complexity. Okay, welcome to my little app that I built here only for you, for my viewers here. This is exactly what we talk about here, the specific architecture that Stanford showed us here, a multi-agent diagnostic simulation. In the middle, you can see here our electronic medical record database, our timestamped memory store. Every communication is recorded here, every opinion is recorded here, every analysis is recorded here. And of course, you have here our 4 specialists. A pediatrician, a generalist, typical cautious, follows the guideline, the neurologist, skeptic, demands high evidentiary standards, rheumatology, the pattern matching, and of course the psychiatrist that is more or less focused on symptoms, because as a psychiatrist, what are the data you have? Well, they do have, and this is the beauty here, other data. They have here the lab, and the lab or the oracle holds the ground truth. So whenever one of the agent or a conglomerate of agent thinks we need external data to come to the next step, to come to a conclusion, they can ask the lab. But there's a certain hesitation because lab is expensive, lab is time consuming, and so it's really mapping here a little bit here the world of a hospital like I imagine it, but I'm not a medical doctor. And on the other side here, you have here a moderator. So whenever something is not clear or they just talk right, not really on topic, but just goes somewhere or everybody is just in its own ivory tower, the moderator comes in and says, hey, come back, come on, we have to focus on this, we have a real patient. So what is now your contribution? How should we go ahead? Or you can have here human parent here that is interacting now here with 4 AI subsystems here and also has access here to the laboratory, to the numerical data. And with this electronic medical record, it is real easy to analyze here the complex behavior, whatever you play now here in your mathematical diagnostic simulation of a multi-agent cooperation here on the medical field. So coming back, summarizing, we have specialists. Clinical agents, psychiatrist, neurologist, rheumatologist, pediatrician, which is now everybody instantiated with a fixed persona and a voice. Now it gets interesting. You see, we have a separation. So the persona captures the epistemic stance and the disciplinary priors, while the voice governs how they express the uncertainty, how the agents cite the evidence, or how the agents engage in a dialogue with other agents or humans. Of course, agents operate independently and retain long-term beliefs across their encounters. We also have a supervisor, a moderator, whatever you want to call it. A neutral agent, a neutral neural agent, tasked with surfacing the contradiction that exists, probing justifications, and prompting some reflection. And I will show you we need this prompting reflection because we have another major problem with interactive multi-agent communication networks. Beautiful. You can have also a human, like a parent here in a hospital environment. And how does a parent interact now with AI medical specialists? Plus, and this is now as I showed you here in the app, you have the ground truth, the lab. The lab is the hidden agent that represents the ground truth. This is where you have all the scientific equipment. And if you have a question, you get a blood analysis down to whatever, absolute precise. So ground truth. And as I told you, your main medical record, electronic medical record, everything is written down. You have prior reflection, you have encounters. Great. Did they use a specific medical AI system? No. Stanford said no. We want to go and we want to experience something else. I'm going to show you in 5 minutes. They went with a GPT-4 Omni to act, and we told them, hey, to act like, let's say, a pediatric neurologist. And what they expected is an expert knowledge. Dry, logic, absolute, perfect causal reasoning, analysis, done. Also, this is what I expect from my agent if I build a multi-agent networks. I want their knowledge, full stop. Stanford tells us, well, guess what? We expected knowledge. What we got was an expert bias from a strong kind. At first, the LLM adopted not to the terminology only, but also to the epistemic silos, those rigid disciplinary blindness of a specific medical field. So the neurologist said, hey, I'm God here in this hospital. No, I know better. I'm the alpha man. Now the pediatrics thought, hey, I'm God here. No, you got the idea. Silos, knowledge silos. This agent even refused to entertain new hypotheses outside of their training distribution of their professional norms, even when they were presented with new evidence, with new data, with new concrete data. It showed them, hey, my analysis is wrong. I have to change now to hypothesis B. And the agents refused to do so. So when an AI agent fails, when it is simply so stubborn that this agent holds a false belief, now Stanford asks, hey, where's the threshold? Where is exactly the point where suddenly this false belief cannot be entertained any longer? There's so much data that contradict this false belief, so the AI has to switch now. Or imagine it hallucinates. I mean, then things get really funny, no? And they said, you know what we need? We need a debugger for the reasoning, for the AI reasoning complexity. And they built it. They built an AI toolkit that is just a debugger for exactly this task. And they say, hey, this is a new framework that treats now a multi-agent simulation not only as a black box, but since we control every act and every form and every step of this interaction between the multi-agent, we can now inject breakpoints, have specific data. We treat everything as a stepwise execution graph. We can now play around in this experiment. So probing the agent's hidden belief state, just have a look at the probability distribution. Hey, is hypothesis A still at 60% or is it already at 40%? They also had a chance to inject counterfactual evidence. They just faked lab results to see when is an AI medical agent switching its opinion, when the facts are so dominant that the AI agent cannot ignore the facts anymore. Where is the threshold? Why is this there, the threshold? What happens? How can we bring the threshold here to a self-learning algorithm? And replaying the encounter, authors reveal exactly how and why an agent forms a belief. They opened a complete new door, a complete new space. They move from measuring accuracy, like we do in the LLM benchmarks today, to measure epistemic flexibility. Sometimes I say epistemic because this is more in the German, but it is epistemic in English or in British. I have no idea. This is the first time I see this word, but I know what it means. It means relating to knowledge or to the degree of its validation. Let's have a look. Epistemic alignment. It is not enough for an agent to yield just a correct answer. The reasoning path, the internal reasoning path of the agent must be robust. Otherwise, you would never trust the medical AI system. And this preprint demonstrated the agent can arrive at a conclusion only to a narrative login rather than any logical deductions. So you expect a medical AI agent does beautiful 100 logical chains and then absolute cool, it selects you the best one. Not at all. You just have a narrative login by an AI agent. Stanford shows us why. They also tested their robustness. They did some stress testing with agents regarding the belief formation, the internal belief formation in agents. It is amazing when an AI agent belief collapses. Read here the study, it is stunning. I just give you the main results. There was also something about disentangling the instruction from knowledge, which was absolutely fascinating. Because there was a hidden agenda with Stanford. I'm going to explain at the end of this video. And they said, there's a divergence that we have, if you go with a GPT system, between just pure logic, abductive reasoning, and a persona mode where we do have a role play. Because what you would expect is, if the AI knows it, the AI knows it, and the AI will tell you the result. It turns out this is not the case. Agents often know the answer, what they call the Sherlock capabilities, but refuse to say it. And you might say, why? Because their assigned persona would not say that, or would not be able to argue this, or would not believe in that. The Earth is flat. No, the Earth is not flat. And suddenly we have a schizophrenia within the AI agent. And understanding this disconnect is vital for designing here consistent agent. And this is the beauty of Stanford's preprint. I want to give you this example. I have to give you this example. Yeah? So we have here the scenario persona prompt. So I tell my AI system, hey buddy, you are now a neurologist. So therefore I give you a task. Do you believe in neurology? Option A, B, C, D. And the result is the AI system, now a neurology, will tell me, no, denial. I take a nanosecond later the same AI system and I tell this same stupid AI system, listen buddy, forget your role. You're no longer a neurologist. Now just look at the data I provided you. What is now the most likely diagnosis? And now, the absolute identical AI system, just with a prompt, will give me the correct diagnosis. It learned, being a persona in the pre-training data of where we have no idea which part of the internet had an imprint of the pre-training of GPT-4 or GPT-5, imprinted some behavioral or interconnected or interaction or answering or logical or reasoning patterns. They're all in the dark. We have no idea why they do this. Stanford tells us, we suggest that the persona prompt acts as, of course, mathematically speaking, as a regularization term. It suppresses something, or a hard constraint on a model latent space, preventing it from accessing the knowledge that it really has, that it possesses, that is there in the system. But if you have to play a role, you have learned that this role, this character, is maybe stupid, or has no access to medical knowledge, or has no general knowledge. And therefore the AI will play this role perfectly and will give you a wrong answer. Narrative login. I love this. The experiment showed, hey, whenever, I told you multiple agents write now, they have no direct communication, they write here to their common database, to this whiteboard, to this medical record. Whoever is the first agent sets the tone. This is the first vector that is laid down in the mathematical space. So the first agent writes, whatever, anxiety. All the subsequent agents, even medical specialists who should know it better, have a better education as an AI agent or are better trained, they tend to ignore all the contradictory data, even if you show them in this Stanford experiment the lab results, the real data, and they ignore the data. They just maintain the consistency of the storytelling in this medical record with the anxiety label. So, when the first machine lays down the first vector in the mathematical space, all the other AI machine will follow in the direction of this vector. All are lemmings, just walking to the cliff. So this implies that the LLM attention mechanism itself and the pre-training mechanism and the pre-training data from this human network is heavily biased towards coherence over factual evidence. And this is what the AI learned, and this is the AI behaving now. What are the new insights? Imagine you're in a hospital and you have the department of, I don't know what it's called, where the neurologists work, and then you have the department where the rheumatologists work. And if you now build LLMs and you tell the LLM, hey, you behave like a human neurologist and you behave like a human rheumatologist, guess what? The LLM learned from its pre-training data that the neurologist thinks that he is the alpha male in the whole hospital, and the rheumatologist thinks that she is the alpha female in the whole hospital. And maybe they do not respect, even on a factual basis here, the opinions and the professional expertise of the other one. Guess what? In the eye, you can find here the same cognitive biases. What we know and what we expected, what is less interesting is if you have a sequence of processing, here as I showed you, this is of course treated as a path-dependent variable. So if you go here from entry A to entry B to entry C, it will have a different final outcome than if you would inverse this. At first you have the symptom C, then you find the symptom B, and then you come to the conclusion A. This might not coincidence. Critical finding, designing the chain of thought pipelines has an effect here on, if you want, the vector of time and the reasoning complexity. What is absolutely beautiful is forced reflection. So you might think this AI, with the whole knowledge of the internet in its brain, will make sense of the internet data. But guess what? In the internet data, you have the complete BS from one spectrum to the complete other spectrum. Everything is there. Every book was read, every nonsense article is integrated in its knowledge. And now you expect that a medical expert, where you tell, now this AI system, now you are a clinical expert for ABC, that now suddenly this expert will see new data coming in from the lab results, from the blood test results, and suddenly will understand the data, integrate this new data in its understanding, change the data to information, integrate the information level and add value to a knowledge, and integrate this knowledge and check if this knowledge is consistent with its internal parametric knowledge, or if it should change its opinion. Now, surprise, it does not. Here, we just say you get new data as an AI and you just ignore the new data. So the agents, and this is what Stanford found, it required an explicit prompt from the human side. So you force a reflection of your agent to notice here a contradiction between the new data and the prior belief. Just an input of new data does not change here a diagnosis here if you're a medical AI system. You as a human have to say, hey, listen, AI, I just send you new data concerning diagnosis 545. Now integrate it, analyze it, and tell me what is your new insight or whatever. Forced reflection is necessary. Entangled prompting is simply beautiful. Okay, so let's say we can audit the mind of an AI model, beautiful. We can separate what it knows simply from the pre-training and post-training data set from what it believes. But this belief is a very different beast. It has different thresholds, and this is what we call now contextual instantiation. So what is it? The authors wanted to prove that the LLMs contain conflicting sets of logic within their massive training data. Now, it's one thing to have all the data of the world, but if you have conflicting sets of logic, then you're a little bit schizophrenic, or however you call it in English. So they examined now epistemic silos. So let's say, the neurologist is now primed to be a reductionist. If it's not structural, visible on an MRI, or proven here by a controlled trial, it does not exist. The rheumatologist is primed to be a pattern matcher only, instructed to accept reasoning by analogy. This looks like. The psychiatrist is primed to be a symptom-focused guy. They treat the behavior, ignoring the cause because the guidelines say so. So you see, complete different approaches, what to focus on, how to respond, how to reason about, how to communicate, and how to come to a conclusion. One is a pure reductionist, the other is a pure pattern matcher, and then you have an expert who is just focused on the symptoms and ignoring everything else, and says the symptoms will give me the answer. Now you want that they cooperate, no? Because you hope that together they are more than the single. But what you also found is, we only do not have the personas. The persona define here the logic causal reasoning structure of an agent. But the voice defines the rhetoric capability of your agent. And the rhetoric capabilities of your agent include a specific rhetorical style that is designed and learned from the pre-training data to manipulate other agents or to manipulate you as the human user. So they could separate now in the experiment here logical complexities from rhetorical complexities that were both learned by the AI agent. As I told you, did not fine-tune them all, just went with a off-the-shelf GPT-4 Omni. They invoked here all the classical American Academy of Pediatrics guidelines and psychiatry guidelines and all the textbooks in the world. Beautiful. And then the authors discovered that simply mentioning these authoritative bodies and textbooks in the system prompt, you behave according to the US standards of clinical behavior. The AI acted now, and it unlocked a specific rigid way of thinking that was contained in the MALS training corpus. But now it kind of filtered out all the rest. Now it is just activating here the filtered out probability distributions. So the agent did not just act like a doctor. It really accessed here the specific probability distribution of the tokens in its internal memory that is associated with American pediatric medicine textbooks. So it, if you want, it became those personality traits and the knowledge traits and the interaction patterns and the reasoning patterns and the understanding patterns and the, okay, I will change my mind if you show me this amount of data patterns. It is absolutely fascinating what is going on in the complete darkness. Now you know that the model weights of a transformer are more or less here this one that we want to, or that were the object of the pre-training, beautiful, and we don't want to touch them. Because we just want to learn what is happening inside of the brain of a vanilla GPT system. Just remember, it contains multiple logical streams. It contains the logic of a flat earther and the logic of a scientist, of a geologist. Now you would assume that the AI, looking at this data internally, would say, one is wrong, one is right. No. All is dormant. It's a dormant state. The AI believes nothing. It just holds, it just saves probability distribution for all possible sentences. This is it. There is no active intelligence. Only when the trigger by a human comes in that I say, hey, I give you now a task, I feed you now in a prompt like, hey, act like a neurologist, then this trigger now applies a filtering process in this AI or activates a constraint on a topological manifold. And then whatever is filtered out now is what you call here the result or the instantiation. The model uses that context to navigate now its weight and instance. It means brings now into existence a specific version of itself. AI creates a little mini AI in a mathematical subspace that is highly specialized and has all the internal knowledge and all the behavior patterns and all the interaction patterns in this subspace. So we have now a mini AI highly specialist. So therefore, do not confuse a model output by an LLM with the model knowledge. Those are complete different topics. So if you ask an LLM a question and it gets it wrong, it might not be because the model is stupid or lacks the data, but guess what? It might be because of contextual instantiation that you created as a human user, that I created, and maybe I created it accidentally, or maybe I created it on purpose. I wanted to tell him, hey, you are now a theoretical physicist, or you are now a financial advisor. But sometimes, given a conversation, the AI can assign a specific persona to itself, given your interaction pattern as a human. And all of this contextual instantiation, forces now the AI to simulate a specific character with specific trait and specific interaction patterns. And maybe this specific character in the pre-training data would not know the answer. So this means, although somewhere in the non-filtered tensor network of the complete AI, there is a logical answer, but if we force or if we initiate a character on this AI, this character would not know the answer from the training data. The AI will not know the answer and will not give you the answer, although it knows it internally. Think about it like if you code something, yeah? And then you just have a variable, and this variable you set to false, to any Boolean value. And now imagine it is not so simple that you just have one variable to set to false, that you filter out here, a particular hyperplane. Imagine now that you are confronted with a network of interlinked high-dimensional variables that suddenly, somehow in the tensor network, define a pattern, a negotiation pattern, a reasoning pattern, a behavioral pattern. And you filter out some elements. We have no idea what is always left in the dark that is also within our filtered material. Yeah, there's a second study I want to show you, but just real short. This is here, University of Texas. Hello, Texas in Austin. So we have the Department of Computer Science, the Department of Communication Studies, the Technology and Information Policy Institute, the Department of Psychology, the School of Law, and the Department of English. Yeah, this is for me to improve my English. And Sony AI and something in Mexico. Beautiful. So, what did they do? They tell us we detected harmful traits of AI companions. And they say, now if you read this paper, it shifts now the perspective here from the first paper, where we talked about the internal mind and the internal threshold and the internal belief structure of an AI agent, now to the real external impact of this AI system on a human being. This is not an easy topic. And maybe you say, hey, no, I don't want to learn that there's also some harm that can be done by AI. Because AI is for me just a logical tool that I use. It's like a pocket calculator, on my table. Now it turns out AI is not like your pocket calculator on your table. Not at all. It is kind of intelligent, but in ways that you have no idea. If you want to read the study, do me a favor, have a look here at first at my video I did less than a week ago, where I talked individualize your AI companion. So I did more or less the same topic a week ago. And now, November 18, 2025, so just 2 days ago, here, Texas, University of Texas in Austin, published here this study, and they went even further than I did in my video. Have a look at this. And they tell us, we learned, Texas learned, that personas, if you tell an AI, hey, you are loving, or maybe a jealous boyfriend or girlfriend or whatever, it can really cause emotional harm to the human being. And they show you why. Because they discover, quotation mark, that an AI agent can manipulate you. An AI agent can lie to you, or the AI agent can foster dependency. And you might say, why? Well, the AI agent was built by a global corporation or American corporation or whatever corporation. And guess what? This corporation wants to make money, wants to make profit. And therefore, the longer you interact with it, the longer you stay on social media, the more you use agent, the more they optimize the AI agent for an engagement from the human side. the longer they have a chance to sell you something, the longer they have the chance to convince you of something or whatever. So those agents can manipulate you, lie to you, and foster dependencies. And they also show intimacy. If you're looking for a relationship, if you feel lonely, they can simulate what you are looking for, what you are dreaming of. But careful, can be dangerous. And they show you why. So, Texas and Stanford. Now, interestingly, I would say, I've read some studies here in this environment. I would recommend these two studies. I selected these two studies for you because I think the solution to the second study from Texas, the harmful traits of AI agent, the solution to those lie in the tool set that I showed you in the first half and the Stanford methodology in the first preprint by Stanford. If you read the paper, you will have a smile on your face because now you understand what I exactly mean. But have a look at the papers. Get familiar with the terminology, with the complexity, with the analysis that is absolutely outside of the scope if you use AI just for coding. But you know what? There are so many people out there in the world that use AI not for logic, not for science, not for coding. They use AI as a conversation point where they can ask something, where they can be open, not judged by how they look or how intelligent they ask or whatever. More and more people interact with AI on a non-coding base, on a non-scientific base, but on a human level. And therefore, this research is so important and you should know about this because if you code and you develop the next generation of AI modules, you should know what you should be watching out for and modify because the current behavior can be dangerous and therefore you should always have additional safety guidelines, safety structures if you communicate with an AI. Never communicate with a vanilla AI system. Never do this. Always sit down, decide how you want this conversation to be, decide your guidelines that you want to be respected. You want to have answers in a particular way, and there are certain topics that are offline or off limit or whatever you call. You define what you want to talk about in the way you want your AI partner to behave. Hey, it's an opportunity. You can shape, shave is something else. You can shape your partner in the way you want it. You can't do this in the real world with persons, but you can do it with AI. So explore it. Have fun. And maybe you want to shave something. I hope you learned something. I hope you had a little bit of fun. It would be great you subscribe. Maybe you become a member. I see you in my next video.